Morning everyone. I'm Mama Ishwari, a Principal Department, R&D Engineering College. This video, we are going to discuss about the subjects, sensors and transducer in that unit 3, force, magnetic and reading sensors. So in this unit, our topic of discussion of today's session is about the strain gauge. So what is a strain gauge? It is an electrical transducer. It is used to measure mechanical surface tension, and the strain gauge is used to detect and convert the force or small mechanical displacement into electrical signals. So, when there is an application of force, a metal conductor is stretched or it is compressed. With respect to the stretching or compression of this metal conductor, its resistance changes with the changes in the length and diameter of the conductor change. And there is also a change in the value of resistivity of the conductor when it is strained. This property is called piezoresistive effect. The resistance of the strain gauge are also known as piezoresistive strain gauges. The strain gauges, it is used for measurement of strain and stress in analysis, and is also used as detectors and transducers. For example, the strain gauge is used in load cell and torque meter, flow meter, accelerometer type strain gauges as a secondary transducer. Now, the discussion about the resistance of the strain gauge. So, we know the general expression R is equal to rho L by A. The change in value of the strain resistance by the application of force, it is explained by the dimensional changes of the elastic material. If a positive strain occurs, its longitudinal dimension, that is x direction, will increase, while there is a reduction in the lateral dimension, that is y direction. And this reverse happens for negative strain. Since the resistance of a conductor is directly proportional to the length and inversely proportional to its cross-sectional area, the resistance changes. The resistance of a conductor is also changed when strained. This property is known as piezoresistive effect. Let us consider a strain gauge made up of a circular wire, and the wire has a dimension of L, A, area A, and diameter D before it is strained. The material of the wire has the resistivity rho. So let a tensile stress is applied to the wire. This produces a positive strain, causing the length to increase and area to decrease. So delta L changes in length, delta A is the change in area, and delta D represents the change in diameter, and delta R represents the change in resistance. So this is the change in delta L, and then delta D, a change in length, change in diameter. Now, we'll go on to the derivation where we define the gauge factor, derive the gauge factor. So L is the length of the wire, A is the area of cross section of the wire, D is the diameter of the wire, rho is the resistivity of the wire, R is the resistance of the wire. We know the formula for R, resistance of unstrained gauge, is R is equal to rho L by A. So we have just now understood what is del L, del A, del D, and delta R. Now, in order to determine the gauge factor, we differentiate this resistance with respect to stress applied, R with respect to S. We know R is equal to rho L by A, differentiate with respect to S. So in the differentiation, first take rho and A as constant out. So it is differentiating the length, it is dou L by dou S. And then area with respect to area, so we'll take this rho L as constant out. So d by dx of 1 by A is nothing but, after differentiation, it is minus 1 by A square dou A by dou S, plus take this L and A as constant, differentiate with respect to rho, so it is dou rho by dou S. So divide the equation on both sides by R is equal to rho L by A. So after division, we have this expression The previous expression is written as such, and we have to divide by the R value. So you get the expression as 1 by R, dr by ds is equal to 1 by L, dou L by dou S minus 1 by A by dou S plus 1 by rho by dou S. Okay. Now dividing by R is equal to rho L by A. So you get this next expression. And we know the area is equal to pi by 4 square. Now differentiate this area with respect to stress to get 2d pi by 4 into dou d by dou S. So here it is 1 by A by dou S is equal to 2 pi by 4d into dou d by dou S divided by pi by 4 square divided by area. After simplification, you get the expression as 2 by d into dou d by dou S. Now substitute this value in the expression. First expression you get dr by ds into 1 by r is equal to 1 by L by dou S minus instead of A substitute as pi by 4d square, and instead of dou A by dou S substitute the expression 1 by A by dou S substitute this expression 2 by d dou d by dou S plus this term comes as such 1 by rho by dou S. Now the expression is done as such. We know what is Poisson ratio, that is represented by simple lateral strain by longitudinal strain, which is nothing but dou d by d divided by dou L by L. From this expression, we can derive dou d by d as minus of this Poisson's ratio into rho L by L. Substitute this dou d by d in the previous expression. And then all these parameters, dr by ds can be represented as delta R, dl by dou S can be represented as delta L, dou d by dou S can be represented as delta D, dou rho by dou S can be represented as delta P, rho. So, delta R by R is equal to delta L by L plus 2B delta L by L plus delta P by T. So, this gauge factor, the definition of gauge factor is the ratio of per unit change in resistance to the per unit change in length. So, we have this previous expression. This expression divide the term by delta L by L to get delta R by R divided by delta L by L is equal to 1 plus 2V plus delta rho by rho divided by delta L by L. Considering this, delta rho by rho divided by delta L by L is very small, neglecting it, you get the expression of gauge factor as 1 plus 2 into V. So, in this video, we have discussed about the introduction of the strain gauge and the theory of resistance of the strain gauge and the gauge factor definition. Thank you, everyone.